Welcome back, Deep Divers. Today, we're diving deep into Apache Spark.
Oh, yeah.
It's a pretty powerful engine,
Yeah.
for handling huge amounts of data,
Mm.
used everywhere from, scientific research
Right.
to those personalized recommendations you see online.
Yeah, it's pretty amazing how much data it can crunch.
It really is mind-blowing. But
Yeah.
here's the thing.
Yeah.
While many people benefit from Spark's capabilities,
Mm-hmm.
very few actually understand how it works, right?
It's true. I mean, it's kind of like
Yeah.
enjoying a magic trick, but having absolutely no clue how the illusion actually happens.
I mean, that is exactly what we are tackling today.
That's right.
We're going to unpack exactly how Spark executes the tasks we give it,
Mm-hmm.
break down those complex processes into something, well, a bit more digestible,
Yes.
and we're going to do it using a rather unexpected analogy.
Okay, I'm intrigued.
Professional wrestling.
All right. That's a new one.
I know, right? It might sound a little strange, but trust me, relating these technical concepts
Okay.
to this world of, choreographed chaos,
Okay.
it will make everything click.
I'm ready to rumble.
So imagine you are a wrestling promoter
Okay.
about to create the most epic wrestling event
Right.
the world has ever seen.
Right. The ultimate showdown.
Your vision for this event,
Mm-hmm.
the matches, the rivalries,
The spectacle.
the spectacle, that's your Spark application.
That's right. You've got this grand plan in your head.
Yeah.
Clash of the Titans.
Yeah.
Incredible storylines, the whole works.
Okay, so I've got my killer wrestling match ideas, my Spark application.
Are ready to go?
What's my first move?
So first, you need to submit your vision, that Spark application,
Right.
to the big bosses, the cluster managers.
Okay.
Think of them like the WWE management,
Mhm.
those folks like Yarn or Kubernetes,
Okay.
who control all the resources and the infrastructure.
So this is application submission.
This is application submission.
Got it.
Ah.
I'm basically pitching my ideas to Vince McMahon himself.
That's it. You got it.
So what happens if Vince gives me the green light?
All right, so if Vince likes your pitch, he brings in the ultimate ringmaster,
Okay.
the driver program,
Okay.
to make your vision a reality.
All right.
This is step 2.
Okay.
The driver program acts as the coordinator,
Mm-hmm.
overseeing the execution of your Spark application.
So the driver program is like the head coach, making sure everything runs smoothly.
Even better, think of it as Vince McMahon himself.
Yes.
He's the one calling the shots, making sure all the wrestlers,
Okay.
or in Spark terms, the executors,
Yeah.
are prepped and ready to rumble.
I like it. So where do these executors fit into our wrestling extravaganza?
Well, just like a wrestling event needs multiple arenas, right?
Right. To host different matches.
Shows different matches.
Yeah.
Spark needs multiple worker nodes
Okay.
to handle all the action.
Hmm.
Step 3 is resource allocation, where the cluster manager, or Vince McMahon, assigns those worker nodes
Right.
based on how resource-intensive your application is.
Okay.
A more complex match with more wrestlers.
Right. Elaborate sets.
Elaborate set.
Pyrotechnics needs more space.
Absolutely.
Makes sense. So the executors are like the individual wrestlers assigned to each arena,
You got it.
ready to execute their moves.
Step 4 is executor launch,
Okay.
where they get assigned to their respective worker nodes and prepare to execute their tasks.
So they're like wrestlers prepping their moves in the ring.
Exactly.
They manage data, just like wrestlers manage their movesets.
That's a great way to put it.
Okay, so we've got our vision submitted.
Mm-hmm.
Vince McMahon is on board.
Okay.
Our arenas are booked,
Check.
and the wrestlers are warming up.
They're ready to go.
What happens next in this epic Spark showdown?
All right, so next comes the choreography.
Yeah, we need a plan.
We need a plan.
Right.
Step 5 is logical execution plan creation, where the driver program, or Vince McMahon, takes your big ideas
Okay.
and starts mapping out the flow of the match.
Mm.
Think of those transformations like map and filter,
Oh.
and actually like count and collect.
Right.
They're all part of this plan.
So it's like outlining the major plot points of the wrestling match.
Exactly.
Who's fighting who,
Mhm.
what kind of moves they'll use, and who ultimately wins.
Exactly. But it's still high level at this point.
Right.
We need a detailed game plan.
Yeah, we need to get down to the nitty-gritty.
That's where step 6, physical execution plan creation, comes in.
Okay.
The Catalyst Optimizer steps into the ring here.
Right, the Catalyst Optimizer. Now that sounds important.
Oh, it is. Think of it as the choreography team, taking those grand ideas from the logical plan and breaking them down into a series of specific moves.
Okay.
They're figuring out the precise punches,
Yeah.
slams,
Yeah.
and holds,
Right.
that will make the match unforgettable.
So it's not just deciding that a wrestler will use a suplex.
Right. But how they'll execute it.
Exactly,
What's
for
going on?
maximum impact.
Oh.
Catalyst Optimizer is aiming for efficiency here, okay? And ensures that those Spark wrestlers are using their resources wisely.
Okay, makes sense.
Now, this brings us to step 7.
Right.
Stage and task scheduling.
Okay.
Remember, our wrestling match has multiple rounds, right?
Right, to keep the audience on the edge of their seats.
To keep the audience on the edge of their seats, build that suspense.
Yeah, it's all about pacing.
Pacing,
That's
exactly.
building suspense.
Similarly, the physical plan is divided into stages, like those rounds.
Okay.
Each stage represents a set of tasks that depend on the previous stage's output.
Okay.
These tasks are then distributed to our executors,
Right.
the wrestlers in different parts of the arena,
Okay.
ready to execute their part of the plan.
So while some wrestlers are battling it out in one corner of the ring,
Right.
others are setting up a dramatic tag team maneuver in another.
Exactly.
It's all happening in parallel. You're getting it. Now, before those wrestlers can jump into action, they need their instructions.
Right.
That's step 8, task initialization.
Okay.
The executors receive their marching orders from the driver program.
Okay.
What data to focus on, what operations to perform.
So it's like each wrestler getting their personalized move list
Exactly.
before the match
Yes.
begins.
You got it.
No, going off script. Got it.
Stay on target.
So they've got their moves planned, but do they need anything else
Oh, that's a great point.
to execute those moves?
Just like wrestlers might need specific props or equipment.
Yeah.
Step 9 is data acquisition.
Okay.
This is where the executors grab the data they need
Okay.
from storage systems like HDFS,
Okay.
S3, or even local disk partitions.
Right.
Think of it as a wrestler grabbing a steel chair for a dramatic finale.
Nice. Okay, we've got our wrestlers prepped.
Mm-hmm.
The stage is set.
Check.
The data is ready.
Yep.
It's showtime.
It's showtime.
What happens next?
All right, now comes the main event.
Here we go.
Step 10, task execution.
All right.
The wrestlers finally step into the ring
Okay.
and execute their moves
Yeah.
based on their carefully choreographed plans.
Mm-hmm.
This is where all those transformations and aggregations happen.
Right. This is the heart of it.
The heart of the Spark execution match.
This is where the sparks really fly, right?
That's right.
Data is being crunched.
Data is being crunched, insights are being generated.
Insights are being generated.
It's a battle of epic proportions.
It is a battle of epic proportions. But
Yeah,
just like a wrestling match might have
Right.
highlight reels played between rounds, right?
right. We got to keep the audience engaged.
Yeah.
Spark needs to handle intermediate results.
Okay.
That's where step 11, intermediate data storage, comes in.
Okay.
These results can be cached in memory or disk for later use.
Okay.
Think of it as saving those epic slow-motion replays for
Right.
the big screen.
So you don't have to recompute everything from scratch.
Yeah. Exactly. Efficiency is key.
Smart move.
Yeah.
But sometimes those wrestlers need to tag team, right?
Absolutely.
And that's what step 12,
That's what step 12
shuffle data handling, is all about.
Shuffle data handling is all about.
Right.
This happens when data needs to be rearranged
Okay.
and moved between executors.
Mm-hmm.
Imagine a tag team match where wrestlers switch places mid-fight.
Oh, yeah.
That's data shuffling.
Okay.
It's all about keeping the action flowing,
Right.
making sure the right data ends up in the right place
Yeah.
at the right time.
At the right time.
Now, here's a point to ponder.
Right.
Why is efficient shuffling so critical in Spark?
That's a good one. I imagine if you have tons of data
Right.
being moved around inefficiently,
Yeah,
it could really slow the entire process down.
absolutely.
It's like a wrestler
Yes.
stuck in traffic on their way to the arena.
Exactly. They're not going to make it in time for their match.
Not going to make their entrance.
Now, after an intense round, the wrestlers report back to the coach.
All right, got to get some feedback.
Step 13, task completion and result reporting.
Okay.
Sees those completed tasks reporting their outcomes back to the driver program.
Back to Vince.
Our ever-watchful Vince McMahon.
Vince needs to know who's winning,
Right.
who's losing, who might need a little extra help
To get back on track, absolutely.
to get back on track.
Yeah, after all the action, there's bound to be a mess.
Oh, yeah, there's going to be some cleanup.
Enter step 14, task garbage collection,
Okay.
where any unnecessary data from memory or disk is cleared out.
Right. Got to tidy things up.
Think of it like clearing the ring of all those broken tables and ladders
Yeah.
before the next match begins.
It's all about keeping things tidy
Keeping things tidy for the next round of
for
action.
the next round of action. Oh,
or exhausted wrestlers need a break.
all right. They deserve it.
Step 15, awaiting new tasks.
Okay.
Sees them patiently waiting for their next set of instructions.
Mm-hmm.
From the driver program.
From Vince McMahon.
Just like in wrestling, there's a rhythm to the matches, right?
Right.
Time for intense action and a time for rest and strategizing.
Okay.
So what happens when the Spark wrestlers are awaiting new tasks?
That's interesting.
Are they completely idle?
Yeah, are they actively doing anything while they wait? Or is it more of a standby mode?
That's a great question.
Yeah.
And one we'll delve into deeper in a bit. Now, for the grand finale.
Here we go.
After all the excitement, it's time to wrap things up.
Okay.
Step 16, application termination and resource release.
Right.
Closes the curtain.
Okay.
All resources are released back to the cluster manager, our WWE management,
Right.
making them available for other events.
Right.
It's like the wrestlers taking their final bow, the lights dim, and the crowd roars with applause.
What a journey. But we're not done yet.
That's right.
Now that we've seen the Spark execution flow,
Yes.
let's meet the team behind the scenes.
Okay.
Those optimization powerhouses that make this entire spectacle run so smoothly and efficiently. Catalyst, Optimizer, AQE, and the Tungsten Engine.
Let's get into it.
Let's dive into their world and see how they ensure our Spark wrestlers are always performing at their peak.
Okay, so we've just witnessed these 16 steps of Spark execution, our grand wrestling spectacle. But just like any great wrestling match, there's a lot happening behind the scenes to ensure everything runs smoothly and efficiently.
Yeah, it's like having a whole team of trainers, coaches, strategists, right?
Exactly.
Making sure those wrestlers are performing at their best and delivering a truly unforgettable show.
And in the world of Spark, that's where Catalyst Optimizer, Adaptive Query Execution, AQE, and the Tungsten Engine come into play.
Okay.
These are the unsung heroes that optimize our Spark execution, ensuring our wrestlers are in peak condition.
Okay, let's start with Catalyst Optimizer. We briefly touched on it earlier.
Yeah.
But how does it actually work? It's optimization magic.
Right. What are its secret techniques?
Yeah. What are its secret techniques?
So Catalyst Optimizer is like a strategic mastermind.
Okay.
Analyzing your code, your grand wrestling vision, figuring out the most efficient way to make it a reality.
Okay.
It's all about transforming those high-level plans into a finely tuned battle strategy.
Okay.
One of its key techniques is predicate pushdown.
Okay.
Instead of processing all your data and then filtering it, Catalyst tries to apply the filter as early as possible.
So it's like intercepting your opponent before they even enter the ring.
Exactly.
You save a lot of energy that way.
You save a lot of energy that way. It's all about minimizing unnecessary work.
Right, right.
Another powerful technique Catalyst employs is constant folding.
Constant folding.
Imagine pre-calculating complex parts of your wrestling match beforehand, like figuring out the exact timing and sequence of a multi-wrestler move.
Right.
That's what constant folding does for Spark code.
Okay.
It simplifies expressions and calculations up front,
right,
reducing the workload during execution.
So Catalyst is all about being strategic, being efficient, and minimizing wasted effort.
Absolutely. But it's not just about being clever, it's also about being data-driven. Catalyst uses cost-based optimization, CBO, where it leverages statistics about the data to determine the most efficient physical plan.
So it's not just brute force, but using data to make smart decisions about the execution plan.
Exactly.
Okay.
For instance, it can decide between a broadcast join and a sort merge join based on the size of the data sets.
Okay.
A broadcast join is like sending a lightweight wrestler quickly across the ring to engage their opponent.
Right.
While a sort merge join is like having two heavyweights methodically approach each other for a power struggle.
I can see how choosing the right move can make a big difference in the overall performance of the match.
Exactly. Now, once Catalyst has determined the best strategy, it needs to translate those decisions into concrete actions.
Right.
That's where physical plan generation comes in. It's like taking those strategic decisions, turning them into executable choreography, specifying the precise sequence of steps for each executor to perform.
So it's like creating a detailed playbook for each wrestler.
You got it.
Outlining every move, every counter move, every tag team maneuver.
And to make things even better, Catalyst works closely with Tungsten, the execution engine we'll discuss later, to generate highly optimized code. Think of it as giving those wrestlers a secret weapon that enhances their speed and agility. Here's something interesting to consider.
Okay.
What are the limitations of a purely cost-based optimization approach in a dynamic environment like Spark?
That's a good question. I imagine if the data characteristics change unexpectedly during execution,
Right.
a plan that was initially optimal might become less efficient. It's like a wrestler having to adapt their strategy if their opponent suddenly changes their fighting style.
That's a great analogy.
Yeah.
And it leads us perfectly to our next optimization hero, adaptive query execution,
Okay. AQE.
or AQE, the ringside coach,
Better.
who can make real-time adjustments
Okay.
to the game plan.
So even with Catalyst's meticulous planning,
Right.
there's still a need for flexibility and adaptation during the actual execution.
Absolutely. Just like in a wrestling match, things can change rapidly.
Oh, yeah.
That's where AQE shines.
Okay.
It can dynamically adjust the execution plan based on what's happening in the ring.
Okay.
For instance, imagine a wrestler is about to execute a complex move,
Right.
but their opponent suddenly counters,
Okay.
forcing them to change tactics.
Right. They got to think on their feet.
AQE acts like that quick-thinking coach,
Okay.
yelling instructions from the corner
Right.
to adapt to the new situation.
So it's like having a backup plan if your opponent throws a curveball.
Exactly. One of AQE's key strengths is dynamic join strategy switching.
Okay.
Imagine you've planned a tag team maneuver
Right.
where two wrestlers coordinate a synchronized attack.
Okay.
But mid-match, you realize one wrestler is much stronger than anticipated,
Okay.
dominating their opponent.
So you might change the plan
Right.
to let the stronger wrestler handle things solo,
Exactly.
maximizing their advantage.
That's dynamic join strategy switching in action.
Okay.
AQE can switch between different join strategies on the fly,
Okay.
depending on how the data is distributed and processed.
It's all about being adaptable and making the most of the situation.
Absolutely.
What other tricks does AQE have up its sleeve?
Another impressive move is dynamic partition coalescing.
Okay.
Imagine, instead of having several wrestlers executing individual moves,
Yeah.
you combine those moves
Okay.
into one powerful combo attack. That's what dynamic partition coalescing does.
It makes sense.
It merges smaller tasks into bigger ones, reducing overhead, streamlining execution.
So it's all about maximizing efficiency, consolidating effort, delivering a more impactful performance.
Exactly.
But what about those cases where one wrestler is completely dominating the match?
Right.
Like those uneven matchups we see sometimes.
That's where skew join optimization steps in.
Right.
AQE can detect those uneven matchups
Right.
where beta is skewed or imbalanced and adjust the game plan accordingly.
So it's like bringing in a fresh tag team partner if one wrestler is getting overwhelmed.
Exactly. It's about balancing the workload,
Okay.
making sure no single executor gets bogged down
Right.
with too much data.
Makes sense.
And let's not forget dynamic partition pruning.
Dynamic partition pruning. Okay.
Imagine removing distractions from the ring so those wrestlers can focus on what matters.
Right.
That's what dynamic partition pruning does.
Okay.
It eliminates unnecessary data partitions at runtime,
Okay.
reducing the amount of data that needs to be processed.
So AQE is like the ultimate strategist.
You got it.
Constantly monitoring the match, making adjustments,
Yep.
ensuring things run smoothly,
Absolutely.
even when the unexpected happens.
Now, all this optimization wouldn't be possible without the raw power and speed of the tungsten engine.
Okay. Tungsten engine.
Think of it as the wrestler's training regimen,
Okay.
building strength, agility, and lightning-fast reflexes.
Right.
Tungsten is all about efficient execution,
Bye-bye.
making sure those optimized plans are translated into machine code that runs as fast as possible.
So Catalyst is the brains.
Yes.
AQE is the tactical genius.
Yes.
And tungsten is the pure muscle.
You got it. One of tungsten's key features is its memory management.
Okay.
It utilizes off-heap memory,
Okay.
which is like a wrestler having a secret stash of energy reserves.
So they're not wasting time on unnecessary cleanup
Exactly.
or waiting for resources.
Exactly. Tungsten also employs whole stage code generation,
Whole stage code generation. All
which
right.
is like compiling an entire wrestling match into a series of perfectly synchronized movements.
Right.
It compiles entire stages of the execution plan
Right.
into optimized machine code, eliminating overhead, maximizing performance.
So it's like having like a pre-recorded, perfectly executed
Yes.
sequence of events.
It's like a highlight reel, but for the entire match.
Yeah. Okay.
And finally, Tungsten utilizes vectorized processing.
Vectorized processing.
It's just like delivering a series of rapid-fire punches instead of a single slow jab.
Okay, I like that.
It processes data in batches, making execution much faster and more efficient.
So tungsten is all about speed and efficiency. Making sure those spark wrestlers are executing their moves with lightning speed.
Precisely. But here's something to think about. While tungsten is incredibly powerful,
Yeah.
it's not a magic bullet.
Right.
What are some scenarios where tungsten's optimizations might not be as effective? What kind of limitations might you encounter?
That's a great question. I imagine if you're dealing with highly irregular data
Okay.
or complex operations that don't lend themselves well to batch processing,
Right.
tungsten's optimizations might hit a snag.
Yeah.
It's like a wrestler who's great at power moves, but struggles with agility and finesse.
Excellent analogy.
Yeah.
Tungsten's strengths lie in processing structured data, performing operations that can be easily vectorized.
Right.
Now, if you're a Databricks user, there's one more secret weapon you get.
Ooh, a secret weapon. Okay.
Photon engine.
Photon engine.
Think of it as an even more advanced training regimen specifically designed for Databricks environments.
Okay.
Photon builds on Tungsten's capabilities, further enhancing its performance by leveraging the unique features and optimizations available within the Databricks platform.
So it's like giving those already incredible wrestlers access to state-of-the-art equipment and training facilities.
Exactly.
But before we get carried away with all these optimization layers, let's take a step back and think about the bigger picture.
Okay.
What does all this mean for us, the non-wrestler Spark users?
Right.
How can we apply this knowledge to write better Spark code?
That's a great question.
Yeah.
And to answer it, let's revisit those points to ponder from the source material, but with a little twist. Instead of just listing Catalyst's logical optimization techniques, let's put ourselves in the shoes of a Spark developer.
Okay.
How can we write code that plays to Catalyst's strengths?
I love that approach.
Yeah.
Like learning the rules of the game so we can play it strategically.
Absolutely.
So what are some tips for writing Spark code that Catalyst will love?
One key principle is to be mindful of data partitioning.
Okay, data partitioning.
Catalyst excels at optimizing operations that are performed within a partition.
Okay.
So try to structure your code in a way that minimizes data shuffling between partitions.
So it's about minimizing those costly data movements and keeping things localized whenever possible.
Exactly. Another tip is to leverage built-in Spark functions whenever possible.
Okay.
These functions are already optimized for performance, and Catalyst knows how to handle them efficiently.
So it's like learning from the best, using techniques that have been proven effective over time.
Exactly.
Okay.
Be explicit about data types.
Data types, okay.
Spark can infer data types. But providing explicit types helps Catalyst make better optimization decisions.
Okay, so it's all about giving Catalyst as much information as possible so it can do its magic.
Exactly. And finally, when it comes to joins, try to choose the most appropriate join type.
Right.
Based on your data characteristics.
Based on your data characteristics.
We discussed broadcast joins and sort merge joins earlier.
Right.
Selecting the right join type can significantly impact performance.
So it's like choosing the right wrestling move for the right situation.
Exactly.
A power move for a strong opponent, a quick maneuver for a more agile adversary.
You got it.
This is all incredibly helpful. It feels like we're peeking behind the curtain and learning the secrets of Spark optimization.
Absolutely.
But now I'm curious about AQE.
Okay.
Since it works in real time, can we influence its behavior? Can we provide hints or suggestions to guide its dynamic adjustments?
That's a fantastic question.
Yeah.
And one that delves into the more advanced aspects of Spark tuning. While we can't directly control AQE's actions, there are ways to influence its behavior by understanding how it reacts to certain scenarios.
Okay.
For instance, by carefully managing data skew, we can help AQE make better decisions about drawing strategies and task partitioning.
So it's about understanding the rules of the game and playing strategically to optimize AQE's performance.
Precisely. It's like knowing your opponent's weaknesses and using that knowledge to your advantage.
Okay.
Now, let's shift our focus to tungsten.
Tungsten, okay.
We've talked about its impressive features, but are there any trade-offs we should be aware of? Does its focus on efficiency come at a cost?
That's an interesting point. I imagine there might be some overhead involved in setting up all those optimizations, like the time it takes to compile code or allocate off-heap memory.
You're on the right track. Tungsten's optimizations do involve some overhead,
Right.
but it's usually a small price to pay for the significant performance gains they offer.
Right.
However, there are certain scenarios where this overhead might become noticeable, especially if you're dealing with very small data sets or simple operations. It's like using a powerful wrestling move
Right.
when a simple grapple would have sufficed. Sometimes the extra effort isn't justified.
So it's about understanding the strengths and limitations of each tool
Exactly.
and using them strategically for maximum benefit.
And finally, let's touch on Photon,
Photon.
the Databricks-specific optimization engine.
Okay.
What are some of the key advantages that Photon brings to the table?
Right.
And are there any situations where it might not be the best choice?
That's a great question. Since Photon is specifically designed for Databricks, I imagine it leverages the unique features of that platform to enhance performance. But I'm also curious about its limitations. Does its reliance on the Databricks environment make it less flexible or portable?
Those are excellent points. Photon's strengths lie in its deep integration with Databricks, allowing it to take full advantage of the platform's optimized runtime, data storage, and resource management capabilities. It's like having a wrestler who's perfectly trained and equipped for a specific arena, maximizing their home court advantage. However, this specialization comes at the cost of portability.
Right.
Photon's optimizations are not transferable to other Spark environments.
Okay.
So if you need your code to run on different platforms,
Right.
you might need to consider alternative optimization strategies.
This has been an incredible deep dive into the world of Spark optimization.
Yeah.
We've gone from clueless spectators to informed coaches,
Yes.
understanding the strategies and techniques that make Spark execution a truly impressive spectacle.
And just like a great wrestling match, there's always more to learn and explore. We've focused on optimizing individual Spark applications.
Right.
But what happens when you have multiple applications running concurrently,
Yeah.
all vying for the same resources?
Right, like competition.
That brings us to the realm of cluster management, where the stakes are even higher and the challenges even more complex.
Okay, so now we're talking about managing an entire wrestling league with multiple events happening simultaneously,
Right.
each demanding its share of the spotlight and resources.
Exactly. It's a whole new level of complexity, and one that requires careful planning, resource allocation, and constant monitoring to ensure everything runs smoothly.
Okay, so let's recap our journey into this world of Spark execution. We started as, those wide-eyed wrestling promoters.
Yeah, those ambitious promoters.
Pitching our grand visions to Vince McMahon himself,
The ultimate authority.
the cluster manager.
Exactly.
And with Vince's approval, we launched our driver program, the Ringmaster,
The one who makes it all happen.
orchestrating the entire Spark execution spectacle,
Absolutely.
coordinating our wrestlers, the executors,
Our talented performers.
across multiple arenas, the worker nodes.
That's right.
We then delved into that strategic planning phase, where Catalyst Optimizer,
The brains of the operation.
the choreography team, transformed our high-level ideas into this intricate physical plan,
A masterpiece of efficiency.
complete with those optimized moves, like predicate pushdown
Yeah, getting ahead of the game.
and constant folding.
Pre-calculating for ultimate impact.
And of course, we can't forget AQE, right?
The ringside coach, always on top of things.
The agile ringside coach, making those real-time adjustments to our game plan, switching join strategies, merging tasks,
Keeping the action flowing smoothly.
ensuring smooth execution even when faced with those unexpected challenges.
AQE is always ready for anything.
And powering all this action was the Tungsten engine.
The powerhouse.
The wrestler's rigorous training regimen focused on memory efficiency, code generation, and vectorized processing,
Making those Spark wrestlers lightning fast.
enabling those Spark wrestlers to execute their moves with, lightning speed and precision. But just as we were celebrating the success of our perfectly executed Spark showdown, we encountered a new challenge, right?
A new
What happens when you have multiple Spark applications
Right.
running simultaneously,
Oh, yeah.
all demanding a share of the available resources?
That's when things get really interesting.
It's like managing an entire wrestling league, right?
It is a whole federation of talent.
With multiple events happening at once,
Concurrent matches.
each with its own unique set of, challenges and demands.
It's a whole new ballgame, managing that complexity.
So how do we even begin to tackle this challenge? What strategies can we employ
Yeah.
to ensure that our Spark cluster
Right.
can handle those demands of multiple applications running concurrently?
So the first step is understanding the needs of each application. Just like a wrestling promoter needs to know the strengths and weaknesses of each wrestler.
Right.
Okay.
Got to know your talent.
We need to analyze the resource requirements of each Spark application, how much memory, CPU, and storage they need,
Okay.
and how long they're expected to run.
So it's about profiling those Spark applications.
Yes.
Understanding their resource appetites.
Yeah. Exactly. Some might be memory intensive, others CPU bound. They might have varying execution times.
Right. Different wrestlers, different styles.
But once we have a clear understanding of each application's needs, we can start allocating resources wisely.
Yeah.
Ensuring each gets what it needs to perform optimally without starving others. This involves setting up resource queues,
Okay.
prioritizing critical applications, and dynamically scaling the cluster up or down based on demand. Think of it as creating a master schedule that coordinates all those wrestling events, preventing conflicts, ensuring smooth operation.
It sounds like a delicate balancing act.
It is.
Making sure everyone gets a fair share of the resources while maximizing the overall performance of the cluster.
Right.
What are some of the tools and techniques that we can use to manage these resources effectively?
So there are several approaches. One common technique is using resource queues.
Resource queues, okay.
We can divide our cluster resources into separate queues and assign each application to a specific queue based on its priority and resource needs. It's like having different tiers of wrestling events, each with its own allocated budget and resources.
Right, so a high-priority application like a championship match
Exactly.
might get assigned to a queue with more resources,
Yes.
while lower-priority task like a pre-show match might be allocated a smaller share.
Exactly. This ensures that critical applications get the resources they need,
Okay.
while lower priority tasks don't hog resources unnecessarily.
Right.
Another powerful technique is dynamic allocation.
Dynamic allocation, okay.
Imagine being able to adjust the size of your wrestling arena based on the number of fans attending the event.
Okay, yeah.
That's what dynamic allocation does for Spark. It automatically scales the cluster up or down based on the workload, adding or removing worker nodes as needed.
Oh, wow.
This ensures that we're not wasting resources on idle nodes,
Right.
while also providing sufficient capacity to handle peak loads.
Dynamic allocation sounds incredibly useful, especially in scenarios where the workload fluctuates significantly. Are there any potential downsides or challenges associated with using dynamic allocation?
That's a great question. While dynamic allocation is incredibly powerful, it does introduce some complexity.
Okay.
We need to carefully configure the scaling parameters, such as the minimum and maximum number of nodes and the scaling thresholds.
Right.
If these parameters are not set correctly,
Yeah.
we might end up over-provisioning or under-provisioning the cluster,
Right.
leading to wasted resources or performance bottlenecks. It's like trying to adjust the size of the wrestling arena in the middle of a match. It needs to be done carefully and strategically.
It sounds like finding the right balance is crucial. We need to be responsive to changing demands, but also avoid unnecessary fluctuations in cluster size.
Precisely. Now, beyond resource management, another crucial aspect of cluster management is monitoring.
Monitoring, right. Got to keep an eye on things.
We need to keep a close eye on the health and performance of our Spark cluster. This involves tracking resource utilization,
Okay.
identifying bottlenecks, and proactively addressing potential issues before they impact performance.
So it's like having a team of expert technicians constantly monitoring the wrestling arena, checking the lighting, sound system, and safety equipment to ensure everything is running smoothly.
Exactly. There are various tools and techniques available for monitoring Spark clusters.
Okay.
We can use web interfaces, command line tools, and even custom dashboards
Right.
to track key metrics such as CPU usage, memory consumption, network traffic, and disk I/O. By analyzing these metrics, we can identify potential issues such as overloaded nodes, slow-running tasks, or data skew problems and take corrective actions.
So it's not just about setting up the cluster and letting it run. It's about actively monitoring its health and performance and making adjustments as needed.
Right, and just like a good wrestling promoter considers the fan experience.
Got to keep the fans happy.
We also need to think about the end users of our Spark applications. We want to ensure that applications run smoothly, deliver results in a timely manner, provide a consistent and reliable experience.
It's like making sure those wrestling fans are having a great time no matter which match they're watching.
Exactly. Factors like application latency and resource fairness are crucial considerations. We want to minimize the time it takes for applications to complete their tasks,
Right.
while also ensuring that resources are distributed fairly among different applications. applications. No one wants to wait an eternity for their Spark application to finish, just like no wrestling fan wants to sit through a painfully slow match.
Right, it's all about the pacing.
So cluster management is all about finding that delicate balance, optimizing for performance, ensuring fairness, providing a seamless experience for all users.
And as we've seen, it's not a one-time task. It requires continuous monitoring, adjustment, and adaptation to the ever-changing demands of a multi-application environment. But by mastering the art of cluster management, we unlock the true power of Spark, enabling it to handle even the most demanding big data challenges with ease.
Absolutely. It's a dynamic and rewarding process.
This has been an incredible journey, from understanding those individual moves of Spark execution.
Right. From the smallest details
To grappling with the complexities of managing an entire Spark cluster.
the big picture.
We've gone from, wrestling
You're
spectator
wide-eyed and eager.
to seasoned promoters,
Calling the shots.
equipped with the knowledge and insight
The tools of the trade.
to orchestrate our own Spark extravaganzas.
And that's what it's all about.
And that, my friends, brings us to the end of our deep dive into Apache Spark. We hope you've enjoyed the show, learned a few things along the way,
Got a little taste of the action.
and we'll see you next time.
Until then, keep exploring.
For another exciting exploration into the world of data and technology.